Once again, welcome to my viewers and students here. We will discuss two very important sums on congruence of triangle. This we are taking from Cbse curriculum, class 9 curriculum. Here it is given that AB is a line segment and P is the midpoint of AB. That means AP equal to BP. D and E are points on the same side of AB. D and E, they are on the same side of AB. These 2 points, D and E, they are same side of AB. Such that angle BAD, this angle equal to angle ABE, this angle. These two angles are equal. And angle EPA, this angle equal to angle DPB. These two angles are equal. Now prove that triangle DAP congruent to triangle EBP. So we have to prove these two triangles are congruent and AD equal to BE. So let us first try to separate out the triangles which are required to be proved congruent. So we will try to write this. We will try to draw these triangles separately here. This is A, P and D, and next triangle is other triangle is EBP. So B is here, E, P is here, and E is here. Right? So we have to prove these two triangles are congruent. Now you are given that P is the midpoint. P is the midpoint means AP equal to BP. This you come to know from the given fact. Right? P is the midpoint, so AP equal to BP. These two sides are equal. Again, you are given that angle EPA is this angle equal to angle DPB. EPA, that means this angle and DPB, these two angles are equal. Now if you add this middle angle with both angles, that means you will find that angle EPB equal to angle DPA. That means angle EPB equal to DPA. So we will try to do this first. So let us prove this. First, you see angle EPA equal to angle DPB. It is given. Now angle EPA plus angle DPE equal to angle DPB plus angle DPE. Just we are adding this angle on both sides. So they will be equal as per Euclid's axiom. We find that when equals are added with equals, the total will be equal. So these two angles are equal and same angle is added on both sides. So when equals are added with equals, then their totals will be equal. So sum total of these two angles will be sum total of these two angles. Originally they were equal and same angle is added on both sides, so total will be equal. So what is EPA plus DPE? EPA plus DPE means angle DPA equal to what is angle DPB plus DPE? DPB plus DPE, that means angle EPB. EPB. Now we will come to these two triangles now. Now in triangles AP, or we will write this same way what is required to be proved. In triangles DAP, and EBP, what are the things we find equal? We find that AP equal to BP given. It is given that P is the midpoint. P is the midpoint means AP equal to BP. AP and BP are equal. Then angle DAP, right? DAP equal to angle EBP. Angle DAP equal to EBP. It is given, right? You are given that BAD means, what is BAD? BAD means angle DAP equal to angle EBP. How do you know this? DAP means angle BAD. Since angle BAD equal to angle ABE. This was given in your question, right? BAD means, what is BAD? BAD means angle DAP, this angle, right? And what is ABE? ABE means angle EBP, this angle. So these two angles are equal. Again we find that angle DPA, this angle equal to EPB. This we already proved earlier. DPA equal to angle EPB from 1 above. This we have proved earlier, right? Now you see in these two triangles we find that two angles and included side of these two angles are equal to two angles and included side of this triangle. In these two triangles we find that two angles and included side of one triangle are equal to two angles and included side of other triangle. So these two triangles are congruent. Therefore triangle DAP congruent to triangle EBP by ASA criteria. This was the congruence criteria that we have discussed earlier, right? Two angles and included side of this triangle are equal to two angles and included side of this triangle. So these two triangles are congruent. Now when two triangles are congruent, their corresponding parts are equal. Corresponding parts, what is the corresponding side of this triangle? This side, BE. AD equal to BE. CPCT. That means corresponding parts of congruent triangles are equal. So this was to be proved, right? Now let us come to next question here. In a right triangle ABC, right angled at C, that means ACB is a right angle. M is the midpoint of hypotenuse AB. M is the midpoint of hypotenuse AB, means BM equal to AM. C is joined to M and produced to a point D. CM is joined, M is midpoint of AB, CM is joined, and CM is produced to a point D, so that DM equal to CM. That means DM equal to CM, right? Then point D is joined to B. Point D is joined to B. This line is joined. Now we have to prove that triangle AMC, this triangle congruent to BMD, this triangle. These two triangles are congruent. Then we have to prove that DBC is a right angle. DBC is a right angle. That means we will say that this angle is also 90 degree. Then we have to prove that DBC congruent to ACB. DBC congruent to ACB. These two triangles are congruent. Then we have to prove that CM equal to half of AB. CM, this line segment is half of AB. So let us see. First, we have to prove these two triangles are congruent. In triangles AMC and BMD, what are the things equal you can find here? See, in triangle AMC and BMD, what are the equal things? It is given that AM equal to BM, right? AM equal to BM. Why? Since M is the midpoint of AB. M is the midpoint of AB. So we find that AM equal to BM. Again, CM equal to DM. It is given that CM is joined to a point D, so that DM equal to CM. It is given. Then we find that this angle equal to this angle. Why? They are vertically opposite angles. Angle AMC equal to angle BMD. Vertically opposite. They are vertically opposite angles. So we find that in this triangle, two sides and included angle are equal to two sides and included of this triangle. So they are congruent. Therefore, triangle AMC congruent to triangle BMD by SAS criteria. Side angle side. Two sides and included angle are equal to two sides and included of this triangle. So these two triangles are congruent. So first one is proved, right? Now in congruent triangles, we find that corresponding parts of congruent triangles are equal. So this angle equal to this angle, right? How? Because these two triangles are congruent. Then angles opposite to equal sides are equal. We find that BM equal to AM, BM equal to AM. So opposite angle of BM is this angle, and opposite angle of AM is this angle, right? Angle DBM equal to angle ACM, CPCT. Corresponding parts of congruent triangles. These two triangles are congruent. Therefore, this angle equal to this angle. Now, if these two angles are equal, you see, it is like that. These two angles are equal. Now, if you see, they are alternate angles, right? And this is a transversal. This line is a transversal of AC and DB. DC is a transversal of AC and DB, and alternate angles are equal. So from this we conclude that DB is parallel to AC. Since DBM and angle ACM are alternate, Therefore, DB parallel to AC. DB and AC are parallel, right? DB and AC are parallel. So you find DB and AC are parallel. DB, AC, they are parallel lines. Now, this is a transversal. So some of these interior angles will be supplementary. These two angles will be supplementary. DB parallel to AC, DB parallel to AC, BC is a transversal, BC is a transversal. Therefore, angle DBC plus angle ACB equal to 180 degree. Now, angle DBC equal to 180 degree minus angle ACB. 180 degree minus, what is ACB? This was right angled. This was given in right triangle ABC, right angled at C. That means ACB is 90 degree. So 180 minus 90 is 90 degree. So we find that DBC equal to 90 degree. So DBC is a right angle. We proved it, right? Now let us come to these two triangles. We have to prove that triangle DBC congruent to ACB. So let us prove this. Now we have to prove that triangle DBC congruent to ACB. DBC, this triangle DBC, and ACB. We have to prove that these two triangles are congruent. Now you see, we already proved that these two angles are 90 degree each, right? BC is common side, right? And we also find that these two angles are equal. These two angles are equal. Since these two triangles are congruent, so corresponding parts of congruent triangles are equal. These two sides are equal, and these two sides are equal, right? So we prove that we find that these two angles are equal. Now these two triangles are also congruent. These two sides are equal, corresponding parts of congruent triangles. So we will prove that in triangles DBC and ACB, we find that BC equal to BC, common side. BC is a common side for both triangle. We can say BC equal to CB or BC equal to BC, same thing. Again, DB equal to AC. Why? Since triangle BMD congruent to triangle AMC. Therefore, they are corresponding parts of congruent triangles. BD equal to DB equal to AC. Then one more thing, we find that angle DBC equal to angle ACB, each equal to 90 degree. Since they are right angle, we already proved this. So in these two triangles, two sides and included angle of this triangle are congruent to two sides and included of another triangle. Two sides and included angle of triangle DBC are equal to two sides and included angle of triangle ACB. Therefore, triangle DBC congruent to triangle ACB by SAS criteria, right? So we find that these two triangles are congruent. DBC congruent to triangle ACB. That means C is proved. Right? Now in congruent triangle, corresponding parts of congruent triangles are equal. We find that therefore DC equal to AB. DC equal to AB. Why? Since they are corresponding congruent triangle, corresponding parts of congruent triangles are equal. Cpct. Now what is DC? We can write DC equal to DM plus CM equal to AB. Now DM and CM are equal. This is already given. So DM plus CM means we can write it as twice of CM equal to AB. Since DM equal to CM. This was already given. So CM equal to half of AB. Half of AB. So we proved the fourth part, question D also, right? CM is half of AB. So thank you viewers for watching this video. We'll discuss some more examples in the next class again. As of now, the video is ended here.